Everyone, today we're going to be working on translating expressions. So first we want to look at some keywords used in math word problems. These keywords are going to help us to be able to write these expressions. So when we're writing expressions for addition, we want to look for some of these keywords in the word problem. Some are add, altogether, and combined, how many in all, how much, in all, increased by, plus, sum, together, and total. Some keywords we might see in a word problem to tell us when to use subtraction might be minus, lost, change, difference, fewer, fewer than, how many are left, need to, reduce, subtract, take away, remain. Some keywords used for multiplication problems: by, double, every, factor of, increased by, multiplied by, of, product, times, and triple. And some words you might see in a division word problem: as much, cut up, each group has, equal sharing, half, how many in each, parts, percent, quotient, ratio of, separated, share something equally. These are just some key terms. There are more, but that's just some key terms that you should look for. Okay. So here we're going to use prior knowledge to see what we know about expressions and equations. Well, an expression can be a group of numbers and or variables together. So for example, I can have 5x. That's an expression with one term. We could have 3x plus 2y. That's an expression with two terms. I can also have 2x plus 3m, the variable doesn't really matter, plus 1. So you can have a mixture of constants and variables with coefficients, or an expression can even just be a term with just a number. So 5 plus 2, that's an expression too. It's just not an algebraic expression. The ones with variables are algebraic expressions. So now we're going to look at equations. Equations really are just expressions, but they actually equal something. So if I have here 5x, I could say 5x equals 10. That's going to be my equation. If you notice the difference, this here is just a 5x. That has the 5x also, but here we have an equal sign. So that's important. That's the difference between an expression and equation. There's going to be an equal sign there, and it actually equals something. So for this example, we can have 3x plus 2y equals 28. Those are all equations. And you could do that for each one, really. But that's the difference between an expression and an equation. Okay, how would you write 4 times a number? What keywords did you use? So we're looking for those keywords. And I'm looking here, 4 times a number. So when I'm looking at that, right away, I would see times. So that tells me I am going to multiply. Now I also have, let me change the color, a number. What number? I don't know. So I'm going to give it a variable. In this case, I'm going to give it the variable n. So now I know my keywords are times, right? That's going to tell me what operation that I'm using. And a number is going to let me know where my variable is going to go. So when I'm writing my expression, here I have 4 times a number, and I made that number n. When we're writing these expressions and there's multiplication, we don't want a dot or a times. That would just equal 4n. Okay. Here we are going to create an expression in words, translate it using the algebra tile. So here we have an example, 3 more than a number. So that means x plus 3, because 3 more than, right? 3 more than means you're going to add 3. So that's why we added 3 to a number we didn't know. So we used the variable x. If we're using our algebra tiles for this, so that means we have x plus 3. Oh, let me take the pen off. Okay, so now here I have x and I have plus 3. So these are my constants, and my yellow is my positive ones and my red is my negative ones. So if I have plus 3, that's plus 1, plus 2, and plus 3. So that would represent x plus 3. If I wanted to do another example, let's say I wanted to do 2x minus 2. I'm going to take there we go. Sorry about that. I'm going to take 2 variables because I have 2 x's. And now because I have minus 2 here, I'm going to take 2 of my negatives. So that would represent 2x minus 2. Now we have 2 different word problems here. So we have 4 is subtracted from a number, and the difference between 4 and a number. So are these 2 expressions equivalent? Justify your answer. So let's look at our keywords. 4 is subtracted from a number. So if you're taking 4 from the number, we don't know what the number is. So let's say my number is n. And if I'm taking 4 from n, that means you're going to subtract that 4. You're going to take that 4 away. So we're starting with our number here, and then we're going to subtract 4 or take 4 away. For the next one, we have, let me use a different color. The difference between 4 and a number. So now we know the differences between them. Difference is another keyword that shows subtraction. But in this case, we're not saying we're subtracting it from. So the difference between 4 and a number, the order is going to remain the same. So the difference between 4 and a number would be written just like that. So now we're asked if these 2 expressions are equivalent. They're not equivalent because if we remember our properties, commutative property where you switch the order, it doesn't work for subtraction, and here's why. Let's just say that n equals 5, and I took my n minus 4, that would be 5 minus 4, that would equal 1. Now let's try it again. N still equaling 5, but now I'm going to do 4 minus n. So 4 minus 5, and that equals negative 1. And those 2 are not the same.